Good evening, everyone, and welcome to this NXP Campus Connect platform. We welcome all the attendees here. Thanks, faculty members, professors, and students, and NXP members to join. Today, we have a very exciting and very popular session, which is, artificial intelligence and machine learning. And we have, Natraj, which is our expert from this field, is visible on the screen. So just give you the background of this, what this NXP Campus Connect is. So, since last 2.5 years, we are running this program and very popular among students community. They are learning a lot. We are getting regular feedbacks, and based on that, we are, improving our session deliveries. And sometimes we are, selecting sessions from their suggestions. So it's a, communication with our audience also, which is very important. Feedback always, improve the things. As you are aware of, every first Tuesday we are running VLI sessions, and every third Tuesday we are running. Third Tuesday every month we are running the system engineering sessions. So today is the third Tuesday. That's why we have a system engineering session where we can, share details about how AI ML is going to be used in the embedded systems and all. Since almost, starting from January, what we did is this time a new feature added, which is basically one of the college is going to host this session. It means that, the college professors, faculty members, and the lab, the guys who are managing the lab and students community will, join through camera. They are visible on the camera, and we will have a live, Q&A session also after the session. So my request to you guys is, you can, note down your queries, or you can type in the chat box, and later we can take that. With this, today, our special, guest, not guest, basically, he is our expert from the IP design team, Mr. Vipin Verma. He is part of the NXP India leadership team and very, popular among universities and campuses. So Vipin, a brief introduction of yourself and say a few words about the program, about NXP in India, and how we can, motivate students about the ongoing, technologies. And right now, time is very not tough, but yes, transformation is happening everywhere. So we want to, listen from you how NXP is going to support this young generation. Over to you, Vipinji.
Okay, great. Thank you so much, Manish. I think there is a lot of ask that you're wanting me to talk about. But first of all, I think I want to congratulate Shivnadar for connecting with us on this Campus Connect program. I think it is something that we do cherish when we have good universities, colleges join us in these programs. So let me first maybe give a very brief intro about myself. So my name is Vipin Verma, and I have been in this NXP in the NXP organization since about more than 12 years. I'm about close to between 25 to 30. I was calculating, it becomes a gray area. Amount of years that I've spent in the VLSI domain during my career, and talking about the the Campus Connect and specifically about NXP India, I think the fact that when I look back, I mean we look at the history of NXP and we see two very big giants from where we've actually created our genetics, our DNA, and that is Philips and Motorola. I mean, when you talk about these two companies, there is a lot of respect that comes in our mind, right? And it is that DNA that we are actually, carrying over into our organization. Everything that NXP does today, and it's really a sense of pride that I have that NXP, whatever NXP does today, is in the field, in the areas which help us in enriching our the lives of the people. Whether it is from automotive or it is in the communication side, whether it is in the sides of industrial, or health, and many other areas that we actually operate in. So, so it gives you a sense of purpose in terms of what we do and when we accomplish and achieve our goals of products and systems that we are eventually able to provide to the ecosystem. Now, uh, beside the day job that I have, which is which is basically managing a part of the digital IP team and creating IP content for a lot of our SOCs. We do spend a lot of time along with Manish and others in a lot of other activities, which are basically to help NXP India grow into a lot of places. Um, One of the areas, of course, is that at the end of the day, we do want an excellent talent to be developed that we can also get benefited from. And but for us to be able to develop those talent, there are a lot of touch points that we want to be able to do in the universities. Campus Connect is one of those many touch points, and I think it's an initiative which is, I can tell you, takes a lot of preparation. Even though it might be about an hour of presentation or maybe less by, let's say, Natraj today, but I can tell you that there's a lot of effort that you would have spent in the background, maybe days and hours to work on those slides and presentations. Same is the case with every presentation that happens. So a lot of effort that goes in there to make sure that students are able to fill the gap between what the theory provides them and what the corporates and the industries actually ask for. It is not a completely orthogonal subjects, obviously, that we teach. Whatever we talk about is fundamentally already provided in the colleges, but it's the application versions or the orientation which allows you to know how will it be translated to when you will actually go and work for an organization like NXP. So my suggestion to all the students, whether they are undergrads, postgrads, and PhDs, is utilize touch points like these, which are being offered, and uh, and and make an effort to get the perspective that is needed by the organizations today, where beside the fact that there is a cutthroat competition in the country and all over the world in terms of the talent that is available. Every organization is looking for people who can be as ready as possible for the type of work that has to be done. Of course, the fact that when you have students and PhDs and postgrads, undergrads, all those sort of students coming in and joining the organizations like NXP, they also are bringing in a lot of fresh perspective, a new thought, and new ways of doing things, and asking questions, questioning established processes. And that is exactly what we also want. We want some amount of churning that should continue to happen into our organizations so that we become better from where we are today. I again, I would not want to stand between you and the presentation today, but my best wishes to everyone, and I hope that sessions like these will be consistently viewed and referenced, so that not just NXP, but whosoever you actually go and work with gets benefited out of this. That's the a part of the endeavor that we have. It's an aspiration that we have to be able to get all of you guys as ready as possible. Thank you, everyone.
Yeah, thanks, Vipinji. Very good. You described it well, and you committed that NXP India is very committed to support all possible ways. And yes, we have a very solid team at 4 locations as on today, and we are always ready to extend full support to them. We have Professor Dr. Naveen Babu and Professor Dr. Rohit. So, sir, welcome to this one, and we want to say a few words about this one, or any feedback or suggestions for us. We'll get back to you on those feedbacks. Over to you, sir.
Am I audible?
Yeah.
Thank you. I'm Dr. Naveen, and I have Satinder Prasad, head of the Department of Electrical Department. And
Can you come closer to the microphone? Your volume, is very low.
I'll come. Okay, I think I'm now audible better.
Yeah. Yes. Perfectly audible now.
I have Professor Dinkar with us, who is head of the department electrical, and Professor Rohit with us, who takes care of embedded systems in our electrical department. So to start with, let me introduce about the university and the department and the few courses that are relevant to the today's topic. We are Shivnadar University located in Delhi NCR, and we are a part of Shivnadar Foundation. And the other higher education institution and schools that we have are Shivnadar University Chennai campus and SSN Engineering College, which has been there for close to 2 decades in Chennai. And we do have Shivnadar schools catering from under the nursery education to class 12, which are predominantly located in Delhi NCR region. And we do have some social initiatives of the Shivnadar Foundation in healthcare. We have Shiksha Foundation, and in terms of underprivileged school education, we have Vidyagyan group of schools. And we are a 286-acre campus. We are an interdisciplinary university. When we say interdisciplinary, we are truly an interdisciplinary in the sense our focus areas, the research that we do are really interdisciplinary. Some examples to tell you are we have an undergraduate research program, which we shortly call it as an OUR program, where students of any branch, any group can approach any departmental faculty to perform their undergraduate research. And the research that is related to this current topic, AI, ML, deep learning, and the NXP, the area that you do, we are a very, very strong group in terms of material sciences across all different 5 schools of the university. Material sciences program is predominantly research in material sciences is predominantly carried out in electrical engineering in areas of organic electronics, nanoelectronics, and the physics department, civil department, chemical department, and mechanical department. They all perform material science research. And similarly, AI and ML deep learning, computer science department caters to a lot of research and courses related to AI and ML. Electrical department does, mathematics department does, civil does. Likewise, all the courses and mostly they are interdisciplinary courses. And you are at the right place to deliver this excellent talk because we understand these languages much better than anybody else. And thank you so much, and welcome to this webinar by Mr. Nataraj.
Thank you, sir. Thanks a lot for your kind words. And yes, we'll collaborate more in future. And with this note, thank you once again for giving us an opportunity to, deliver this session to this community. We have a lot of other experts, a lot of other audience from different colleges also online. With this note, thank you, Vipinji, and thank you, professors from Shivnadar College. With that, we have to start our session today. So a brief introduction of Nataraj, who is having, 30 plus years of industry experience, experts from this domain. Apart from, AI, ML, he is also, experts in application processor, compute design, which is CPU, DSP, GPU, NPU, a lot of stuff. I'm not able to describe, Nataraj here, but yes, I think welcome, sir, to this platform, and thanks a lot for all your effort. And we are eagerly waiting for your session. So a brief introduction of yourself, to start with, and then, you can start your session. Over to you, sir.
All right. Thank you. Thanks, everyone. Thanks for joining. It's late evening for you guys. I'm based out of Austin, Texas. It's early morning for me. And what I do, I work at NXP. I lead the machine learning software development team. And what it means is like we work on tools, inference, and provide embedded software, embedded ML software enablement to our customers. And about myself, I have very good experience in the embedded world, wireless networking, and then lately the past 6 years or so on machine learning, and mostly involved in enablement software. Enablement software is like there is a silicon, and then the silicon needs base level drivers and the software framework for customers to develop applications on top of that. So we provide enablement software that's broadly connected to our SoCs that connects peripherals, and also in this particular case, machine learning accelerators, machine learning compute libraries, and so on. We'll go over some of those basics, and machine learning is a vast field. Um, we'll do some introduction a little bit, and then we talk about NXP's EIQ. This is the edge intelligence software. It consists of tools and runtime inference engines. And then we'll take a specific SoC that's provided by NXP for as IDOTMX 93. That's the name for the silicon, and then we go over the features of those and conclude on how it can be used and what kind of applications it can be used. So we'll go into the fundamentals. So majority of machine learning is around calculation, right? It's different types of calculation. So if you want to predict continuous values, like you use regression type of calculation. If you are looking for recognition, that's on the classification side of things. Is it a dog, cat, cow, objects? Those are the kinds of algorithms that you would be using. And there's also anomaly detection. Are there any abnormal data that you're seeing in a particular set of data? That's the anomaly detection. If you have patterns, if you have a large set of cluster data, like, okay, can we find a pattern on that? That's also machine learning can be used for there as well. And there are different learning strategies. Supervised, unsupervised, reinforcement learning. These are the types of, so like I said in the beginning, it's a vast area. And the deep learning comes in as well. And there are many more evolution is happening in this field. It's an exciting field to be in. If you want to do, let's say, some sort of prediction, use the regression algorithms. This is more of a shallow learning kind of an algorithm that you can use. And if you want to do anomaly detection for finding unusual occurrences, you could use anomaly detection algorithms like SVM. And like I said, like the clustering of data, if you want to discover a pattern, you can use clustering algorithms. And then prediction categories are like, okay, in some cases it could be just a two-class classification or multi-class classification, whether it's dogs and cats and objects, chairs, computers, mouse, keyboards, whatever you want to do predict. So the rule of thumb consideration for machine learning, especially the deep learning area, is like you use pretty much everybody is using CNN, convolutional neural networks, for object recognition, image classification, and anything to do with computer vision. And anytime that you see time series data like speech, it's a continuous data, you use RNN networks. And when you have a large set of data, that's where you use deep learning, deep neural networks. And when you have a smaller data set, you use classical machine learning. This is basically shallow learning. And in general, there are two steps, a two-step approach for developing machine neural network. One is the training phase, the other one is the inference. What is the training phase? You bring in a large set of data, and you apply, you go through neural network computation, and then you provide the feedback as like, okay, let's say you have a human face that you wanted to detect, and it comes up with like something different, and then there is an error. So you feed that error back to the learning phase, and then continuously do this learning till you get to a certain accuracy. So that's on the learning phase, the training or learning, how you want to call it. Training takes a long time. You need a large data set, especially for deep neural networks. You need large data sets. So we are talking about um, thousands and millions of data set. So what is a data set? You have an image. Let's say you have dogs and cats. You want to have different types of dogs and cats in different position, orientation, and start to work on the neural network so it learns the features and then starts to predict in a better order. So the training takes, if you have like good GPU environment, like hours and days data set, and sometimes weeks to do the training. And once you do the training, you get the so-called the model. And once you have a model, you can provide input data that the training data set did not have, or it has, and then pass through the neural networks, and then it makes a prediction. That's the inference phase. Edge AI is mainly on the inference phase, which means the training happens somewhere on a powerful GPU machine or in the cloud with a lot of resources. And the inference happens mostly on the edges, like as far as NXP is concerned. And let's say typical applications on the vision side, you could have a CCTV camera, or in the industrial environment, it could be part of the manufacturing assembly line. And it takes an image and then um, predicts what's out there. So it can be continuous feed of an image that becomes a video or live data. So that's the inference side of things. And the inference is expected to be at a frame speed. It's like 30 frames, 60 frames per second, or even better than that, because you need a lot of computation resources to perform other activities in the end-to-end loop. So this is the inference part, and then so say for a data set or a model, it's very old data set. I think it's about 60,000 images. It has 10 classes. And what it does is, like, you can develop a model like, okay, you can introduce 3 convolution layers and pooling layers and then a fully connected layer, and you get like something like a 80% accuracy if you train it this way. And more information is available. This is a standard data set. And what you have here on the right side is like a particular class and many types of data. And so you can see that maybe the car is the dog is more visible. You can see different types of dogs out there. So you feed in these kinds of input into your training phase, and later on you could feed in a live picture or a video of a dog image, and then this neural network should be able to predict. Looks like I'm hearing a background, but hopefully there is no question there. All right. So EIQ machine learning software development environment. What we mean by that, it is collection of development tools. We provide training, validation, and the deployment phases. The training is, like we discussed earlier, provide a large set of data. You do the model development. Model development can be like the example in the CFAR network. It's like, let's say, 3 convolution layers, 3 pooling layers. You could go um, deeper and also a custom model with the tool. So what we offer in the ML software development environment is the training part, and also validation and deployment. We'll go over those today. And then on the deployment, you have the inference phase. So why we developed the toolkit? So tools is offline. You do the training. It's for entry-level engineers or to all the way to experienced ML experts. What it does is like it allows you to bring in your own data or your own model and then do data curation. Let's say you have your own data set, which means that in this particular example, we're going to see, let's say you have playing cards. So you bring in your own data set. It could be a single card, multiple cards, and so on. Those are the images. That's data collection process, and also how you do the data curation, what resolution it is it black and white, is it color, and the format of the image. All of this comes under data curation. Once you have a data curation, you do augmentation of the data. We'll go over that. What the augmentation is basically expand the data set. If you have 100 images, how do you make it into 800 images or 1,000 images based on certain types of algorithms? And that's how you expand the data set. And once you have the data set, you create a model or use the provided model from the toolkit. You do the training, and then you do optimization. And on the edge inference, the very key part of the edge inference is quantization. Quantization is the model is on 32 bits floating point, and you want to reduce it to 8 bits or less. And the integer format. What it allows you to do is like it allows you to shrink the model for memory efficiency, and also it increases the compute. Floating point computation is very expensive, and integer computation is pretty fast and easier. And then you do the model validation. Model validation is you had the prediction, you did the training, you have a lot of input data and or test data, and then you can do the test for that model. So we do the model validation, all part of the toolkit. And then once you're satisfied, let's say the validation it says like, okay, here is the predicted set of data and the actual. So you map it and see whether your model is functioning to your expected accuracy. Then you go on deploy on the board or on the edge device, and then you take it from there. Just give me a second. It's an interrupt. Sorry about that. Sorry about that. On the inference side, what we do, we provide different types of inferences for different types of applications. The inference, we provide inference engines that we support, or TensorFlow Lite Micro, TensorFlow Lite, GLOW's a compiled environment, and also a proprietary inference engine that we have is called DeepURT. So we provide different options for our customers, and they can run it on the CPU, DSP, or CPU, DSP, GPU, NPU, and so on. So that's on the device inference side of things. And so how does the tool look like? It's a very simple tool, easy to use. And you create a project and then provide the data set around it. And if it is bring your own data set, and if you have bring your own model, which means like it's pre-trained in a different environment or downloaded from a different place. Looks like there is a question. I guess not. So
Hello. Hello.
Yes, go ahead.
Sir, I just want to ask about what is the approach of building algorithms for the training model? Like you develop it on predefined data set, or you create it using like different beforehand logic, or you use exceptions, or how do you correlate the data set and the algorithm for the training model?
Yeah. So that's they bring your own data set and then you develop the model on it. Like, so we'll go over that. So I think earlier, beginning of the call, it was mentioned that like we'll provide some time, we'll reserve some time to ask questions. I think it'll be better that way so that like everybody in the call can go over the entire material and then we can ask questions. I know it's a little bit of non-interactive, but at the same time, we have limited time. So let's go over the flow. And ask the questions at the end of the session. Maybe I'll go a little bit faster so that like we can have questions on the end. So to answer this particular question, good question. How do you have bring in a data set and then develop a model? Um, we the tool offers that, but in general you have a data set and then you need to associate that data set with a model, and the model has like okay whether it's a C4 10 model or it's a MobileNet and all sorts of models out there that you reuse, or you can develop your own model. It's called custom model in our tool set, and you can play with it. Traditionally, you take some base model and then build on top of it. That's a a recommended flow. And then we also offer command line tools. So everything that you see on the two tools, GUI interface, if you're not a GUI person or if you don't want to use GUI, you can use command line options where you run it through scripts or commands. Uh, so we also have converters. Converters are like model format converters going from Onyx, which is PyTorch is output, and then TF Lite or RTM is our DPU RT converters. So we have plugins. The tool has plugins. We allow our partners, not a user, but our partners to develop their own converters from whatever model format that they think their customers bring in, and they can bring it into the toolkit. So we have a way of getting our partners work synergistically with us. And the converters formats are going from Onyx to TensorFlow Lite, um, and also on the DPURT. Basically, you do the transformation from one format to the other, whether it's a Keras model, TensorFlow, PyTorch model, you can convert it to a TensorFlow Lite or DPURT and then perform the inference. So there are many phases of transformation of the model. We talked about optimization, quantization, and then there is a conversion, and this is a conversion part. The toolkit allows all of these. So data curation, we talked about bring your own data set. So in this set of playing cards data set, you have different combination of data. And this is the curation part where you label these as jacks, kings, queens, and so on. And also you have the background. So what you could do is like you could um, uh, crop the image however you wanted to have it, like without the background, with the background, different types of background. So these are the curation part that you wanted to add to the inference to the data set. Also, once you have these data, you want to do some sort of augmentation. What is augmentation? Like, let's say these data set, like you can see on the left side of the screen, like the picture, you have A's and Jack. The ace of spades is like inverted. So if you want to create another picture, it's going to take a while. So we offer algorithms. You can say, okay, rotate 180 degrees. You can flip the image however you wanted to do. So these are the options, and there are many more options. You can say, okay, every image that you see, do these. These types of augmentation, you got to be careful with the traffic signs. So other than that, you should be able to uh, augment. So care should be taken on some of these images. Let's say you have a left turn and then you flip the image and then you train it as a left turn. That's not good. So you need to make sure that you understand the data set and then go with the augmentation phase. Just And then there's also all sorts of brightness, hues, saturations, everything that you can do, and then work on model selection part. Sorry again, got interrupted. I have to be attending this. I'll be right back in 20 seconds. Sorry.
No. Oh, go ahead, do your thing.
All right.
I texted you just to let you know.
Okay. All right. Sorry about that. So what we do on the model visit, somebody asked the question of how do you do the model selection? That selection process is if you want to do a classification or detection, you can use that tool to guide you through this. And you can either restore the base model, restore the model, use a base model. Base model is like, okay, we provide MobileNet V1 as a base model. And then user models, like you can create your own custom models. And then we offer a performance balanced accuracy optimization phase. So if it is performance, like you can compromise on some of the memory. And if it is accuracy, you can't really sorry, it's the other way around. If it is a performance, like you want to make sure that like, the computer is less, and for the accuracy, you want to make sure that you compromise on the memory, but accuracy is very important. Or you want to mix the balanced approach. So we offer these, and then on the device type, okay, do you have a CPU, Cortex-M, Cortex-A? These are the CPUs that we offer. And then GPUs, NPUs, DSP, all of these compute engines we offer on the device side. And this is the flow that you go through. So if you're a user, if you're a beginner, intermediate, you can use this click through option. And then once you are familiar with it, like you can go customize each phase that you want on the model side of things. So the base models that we offer, like MobileNet, on the edge side, MobileNet is very popular. It's efficient for edge devices where the compute resources are scarce. You can use MobileNet V1, V2, V3, SSDs. These are the detection models. And you can also bring in your own custom model. And in the training process, you can always do a checkpoint and you can bring in the restoration points. On the training, so we provide the view of the training with the tool. There are a lot of parameters that you can use. What's the input size and the weight initialization. We can start there a little bit and then pass through all the other options. Given a model, you need to initialize those model with some weights, and the weights can be either random or based on some predetermined weights. There are, like, you could use ImageNet, which is a popular data set. The weights that comes out of that training, it's you can use that, or use a random data as a starting point. And the input resolution is like one in this particular case, we have highlighted 128 by 128. There are, depending on your model, your data set, resolution, and the object, you can vary those. CIFAR, for example, they do it 32 by 32, and it can go all the way to whatever resolution that you want. Keep in mind, the larger the resolution, the more the training time, the more the training inference, training resources are required. And also on the inference, it's going to take a long time. So there are many parameters in the training. We provide some default training options, like, okay, these are the options that you have. You can click through all these, and we provide default settings, and then allow you to do the training. Why we do this? Like, it's like for a beginner, and also like some cases, expert users may not be aware of all the parameters that are required to do the model training, and they don't have to understand all of these in some cases, depending on what they're doing. We allow for default values, and then you can go plus or minus whatever the required optimization that you want on the training side of things. So at the end, you get a model, and that model, you can do a validation. So the confusion matrix is produced, but during the validation phase, okay, what is the actual data? And what's the predicted data? So if it's all on the green, you want to see everything on the diagonal, and you can see some are red and pink, which means there is a prediction. So if you click those, you will get those data, and you can see what you wanted to do it, like visually. And if you want to augment it, you can do different types of augment, or if you want to, like, okay, add more data set for that particular class, you could do that. So this view provides you a good way of, all right, add more data set or see why certain things are going wrong, and this is what you do. And then you can also do the class accuracy. Class accuracy is true positive, true negative, false positive, false negatives. These are the kinds of things that you can look through. And then once you're ready with it, you could connect directly from the tool. If you have a board, NXP's board, it's an evaluation kit we offer for various SOCs that's machine learning capable. It's available in our website, and you can, once you have those devices, you can connect to those remotely and run it through on the device itself to see how it performs. So you have a PC environment which produces the confusion matrix, and then you can run it on the device and see, okay, how it performed. The validation on the target is allows you to do that, right? And then once you have a model and you're satisfied, you can export that model to a particular format that supports your inference engine. So again, going back to the validation on the target, provides you different data set, different inference latencies. And you are happy with a particular inference engine, let's say TensorFlow Lite, you can say, all right, I wanted to move this model to TensorFlow Lite environment, and you can run the inference and go on from there. So once you have a model, you can visually use the tool to look at what are all the operators that are available, what's the dimension of it, what's the input shape, output shape, and so on. And each model at each layer you can inspect and see what it is. So the tool offers this. Netron is a open source tool. We use that as a base. And we also provide profiling information, which means run it on the target. And then you can see, well, what's the combinatory uh, execution time, and you can see all these profiling information. This allows you to develop a better model that's targeted to a particular board. In some cases, some NPU may be performing better, and some CPU may be performing better in one of these operators. So you want to know all that as a user, and we provide those profiling information. And if your model allows for flexibility in changing a different types of operator, you want to change it and experiment it. So that's why we provide this model inspection tool, where you can look into it, see all the attributes to it, and also the profiling data. And the command line looks something like this. You can do import, validate, convert, and run it on the device. We also provide the Jupyter notebooks with this data. So now we look at the edge device. At the beginning, we said like we will look into a particular SoC. This is the one of the NXP's SoC, which is IRMX 93. What it has is it has two ARM Cortex A55, one Cortex M33 that's running at 250 megahertz, Cortex M and Cortex A are the processors. These are ARM processors. And then it has an NPU, neural processing unit, which is the Ethos U65. This is an IP provided by ARM. We integrated into our SoC, and we provide enablement software for those. And there are many interfaces, graphics, camera interface, audio connectivity. All these interfaces are available on this board. It can go as in the IoT environment, industrial. It can do vision, audio processing, anomaly detection. All of these can be done with this particular device. It is a very efficient, power efficient device. It doesn't need a heat sink or a fan. These are the kinds of things that you look for on an edge device. And then it can also do a good machine learning inferences. There are many features on the SoC. I'm not going to go over all of those, but suffice to say that it's a very secure device, and it has many peripherals that can address a wide range of IoT, industrial, smart home, smart city kind of an applications, and it also has an NPU. So yeah, where is it targeted? Industrial automation, smart home, smart city, building control, all of these. These are the areas that you can take this device and apply it, and to do classification, detection, human-machine interface. You could do smart lighting, and a lot of applications can be done. And not everything is listed here. It's up to the user customer to use these fundamental building blocks and develop their applications. So we provide fundamental foundational technologies for machine learning, and we let our users do their research and be creative and develop their own models. Very quickly on the Ethos, Ethos U65, it's a micro NPU. It has SRAM and DRAM. SRAM is a fast RAM, and DRAM is slower RAM, and it can store a lot of data on the DRAM, and the SRAM you can only keep so much, and but it's very fast, so you can do a lot of good computation. And the Cortex-M it controls the Ethos U65, and the Cortex-A runs Linux, QNX, and even RTOS. If customers are familiar with it, they can go develop theirs. But we provide Linux as a foundational technology, and you can use Linux and develop your software on top of that. Again, applications like facial recognition, object detection, gesture recognition, everything can be built on top of this. So the board looks like this. You have a compute module in the middle, and there is a base model, baseboard. Baseboard supports all sorts of peripherals, including display, camera interface, and other peripherals, UART, Ethernet, and so on. And the compute module supports power measurement circuit and also the IMX device. And the board looks like this. As you can see, this is the NXP Silicon i.MX 95. All sorts of components are there. Ethernets and LVDS display and so on. It's a fun board to work with. A lot of options available on these boards. And some applications. So you have LVDS, LCD display that comes out of it. This goes to an edge device, and you have to have that context. There are so many variables here. It's not a plug and play camera from traditional places, but this is you have to purchase these kinds of items. Like there is a camera here, LVDS display, and so on. This is a video coming from the camera displayed here, and more description of the i.MX device. And finally, on the board itself, when it comes up on the display, you will see live demo options like image classification, detection, video detection, depth detection, and so on. So these are the applications that are readily available for someone to make an observation, and then you can take that and then build on top of it that suits your needs. So this is also provided as part of the board. So why we are going in this direction, machine learning is a vast field. If you want to try out end to end, it takes a long time to get there. This is one option to get there faster and start to learn somewhat like from bottom ups. For more information, you have it on nxp.com /AI. We also offer some of the software training. There's training materials on the toolkit, on the MCUs, the microcontrollers, and also the MPUs, microprocessors. We have bring your own data training, bring your own model training, and so on. So these are the training materials that are available for the end user. Some of them are hands-on labs as well, and you can play with it, and then you need a development board to experiment it. But EIQ is provided as a software tools, and it can be used on a NXP hardware. With that, I conclude, and we can have Q&A. I know I rushed really fast. If there are many Q&As, we can go over, and if we'll open the floor for Q&A.